So why that is there is you can become.
So you have to vectorize. So your x raised to power 2, before the operator you put a period. So it's going to be equal to f equal to inline x dot squared minus sine of x if you want to suppress it so it doesn't show, you can suppress it. Then so I'm going to define x equal to the vector, remember equation, and gives you 0. F equal, we want to plot f of x against t. Now I want you to generate a vector t. This is your initial value, this is your increment, and this is your final value. So in this case now the final value is 20, the initial value is 0, and my increment is 5, 10, 15. So it's going to be, so t is going to be equal to 0, 5, 20. And to plot this f of x against t, f of x is the solution to this when this vector was inputted to the formula. So if you there is no need because t is already defined. T is defined as the vector which this is giving you. T is defined, so it's going to be plot t, f of x. And what is f of x? 5, 20. So you can see the graph commands we're using at this point. Cos 0 is equal to 1. The sine of 90 is equal to 1. The cosine of sorry? Cosine of 180 is minus 1. So you can see that if we compute the sine of all the angles from 0 to 360 and the cosine of all the angles from 0 to 360, we are going to be able to draw a unit circle. The mean space, the cosine, the sine, and the plot. Now the figure, when you plot it, we can just type the file name, the script file name, circle 1. So you can see our unit circle on the figure that came up. I'm going to introduce a for loop here. The for loop executes a line of a statement for a fixed number of times. So we're going to say for k equal to 1. Remember, how do you find the factorial of a number? For 5 factorial is going to be 5 times 4 times 3 times 2 times 1. So you can see that it's reducing by 1 each time. Right? So I want k to start from n, from whatever n is for n dot. Minus 1 is the increment dot 1. To solve the factorial, I'm going to say q is equal to q times k end, and the argument n, that's the input. Now I've labeled n equal to 5. I've initialized my function output, which is q. So we want a situation where the user is going to input a number, input some value, and it will compute the factorial. We are going to use the Matlab command called input. So n equals to input. Please enter number. Has everyone achieved that? As you can see on the screen. So you can see that when you call the function, the command window is going to ask you to enter an input. When you enter the input, the command window will return the answer. So in that way, your function can compute the factorial of any number that you are entering here as n in this line. Matlab is not a subject. Matlab is a software that is applied to solving problems. So for you to use Matlab, you need to understand the subject you are trying to apply Matlab to. So for example, if you are going to solve an engineering mathematics problem, you have to know the engineering mathematics aspect before you come and start trying to use Matlab. It's of no use not knowing, for example, if you are going to solve this problem, you need to know how to solve Simpson's rule or any of the other methods of approximate integration. So this from Simpson's rule, the area A is equal to S over 3 bracket F plus L plus 4 times E plus R. So this is the formula. Now F is the first term of the length, so this is your F. L is the last term. Now n minus 1, because it's going to start from when n is 4, n minus 1 is 3. When n is 5 is 6, n minus 1 is 5. So now we want to write a Matlab program that will compute this. So your Matlab program is going to be equal to the integral of y dx. The area, yes. The area under the curve. So we're going to introduce the second for loop. This for loop is going to solve this first summation, and we need another for loop to solve this summation here. For I equal to, now we're going to start from 3, the third term, 3. Then it's going to go all the odd numbers. So it's going to be 3 and it's going to move, it's going to increment by 2. So that will be 3, 5, 7, and so on and so forth. You know, the terms are even, so it's going to go up to n minus 1. Now remember, then you put what you want this for loop to compute. So I want to compute sigma 2. 2 equal to sigma 2 plus 2 times Q of I. And now remember, sigma 2 is the variable I declared for this summation. It could be anything you name it, as long as it's not the standard Matlab command. So you could name it your name or anything. But I'm using sigma 2, so I can relate it to this summation.
It can even be a single letter.
It can be a single letter. Plus 2, that is 2 times Q of I Remember, this is Q, so I now compute A. So we now say A is equal to. Now remember S is the strip, is the width of the strip. So you're gonna launch a script file on your Matlab window. On our script file, we have X, we have the matrix X giving us the ordinates. And remember, this length is a Matlab function that gives you the length of the matrix. So we use the function length of X, which is the length of 1. Solve this equation, which is the equation of Simpson's rule.